10-3 operations with radicals. The big idea here is that you can only add things that are like. So this is taking you back to kindergarten, where we added images like smiley face plus 3 smiley faces is 5 smiley faces, and adding negatives such as -2 and -4 equals -6. Because they're both negatives, we can add them. These are both positives, we can add them. For 1/2 and 1/3, those weren't common denominators, so we couldn't add them until we made them common, and then we could add them. With decimals, we can only add like place values. So I added my hundredths, then I added my tenths, then I added my ones place. And with variables, I could only add like terms. So I added my x's, and the y just stayed. The whole point of teaching you that was so that you would see that even with radicals, we can only add like radicals. So I can add 10 radical 6 and -4 radical 6 to get 6 radical 6. And for the radical 3's, I can add those to get 1 radical 3, which I write as radical 3. And then I'm done. This is my final answer. This was example 1 off the packet. Here are practice problems 1, 2, and 3 from the packet. Pause the video and try it, and then I'll give you the answer. Here are the answers for 1, 2, and 3. This is example 2 off the packet. As you can see, our radicals are not simplified. 12 can be broken down, so I did a factor tree. And 75 can be broken down, so I did a factor tree. My pairs that could come out were a pair of 2's, but remember that I had a 3 outside, so I have to multiply those. 2 times 3 is 6, and I put my leftover 3 inside the radical. For 75, I had a pair of 5's. That comes out, multiply it by 5, and I have my leftover 3 going into the radical. Now I have like terms, so I can add those, and I get 31 radical 3. Turn to the practice problems and try problem number 4. And when you're ready, go on to the next slide, and I have the answer for number 4 for you. So once I simplified my radicals, like radical 28 and radical 63, then I wrote out all my simplified radicals and combined like terms. It's not always going to tell you to use FOIL on these multiplying radical expressions. You have to know if you're going to use FOIL or regular multiplication or distribution. And so we have, in this case, we have a binomial times a binomial. So that's how I know that we're going to use FOIL. So I start with my first, 3 radical 2 times 4 radical 20. Multiply the outside numbers, 3 and 4, I get 12. Multiply the radicals, 40, so 12 radical 40. Then I do outer, 3 radical 2 times radical 8 is 3 radical 16. Then I do inner, -2 radical 5 times 4 radical 20 is -8 radical 100. And then my last, -2 radical 5 times radical 8 is -2 radical 40. I simplified every one of these. The 2 middle numbers came out as whole numbers because these were perfect squares. And once I had everything simplified, on the bottom is my simplified answers. I then combine like terms to end up with 20 radical 10 minus 68. This is number 7 from the practice problem, so you can try this and make sure you get the same answer that I have here.